Hello everyone, welcome to Handmade Hero Show. We code a complete game live on stream. We're doing some API stuff today, which I think is good and important. I know it's probably not the most exciting thing. Everyone would rather code explosions or something, but API design is probably one of the least well done things in the entire industry. Most APIs that people ship are just absolutely terrible. And so spending time learning about how you would brush something up and rework parts of it in order to create a good design for an API is valuable, not just because if you're ever in the position to release a tool to the public, it's very nice to have some experience designing APIs so that you release something that's usable and good. That's certainly the case, but also just even for your own purposes, like I kind of said, pulling out this render is good because someone else might get a chance to use it, but the other part that's really important is that it just makes it easier for us to use. So when you spend a few hours going through and cleaning up a piece of the code surface boundary, right, like between the renderer and the game or something, by cleaning that up, it gives you a chance to do that polish work that can then pay dividends because now everything is more well thought through, is more well specified, right? So you've decided things like, do you specify things from the center outward or do you specify them from the bottom up? And like, by bringing that extra layer of consistency into the API, it just reduces frustration. It reduces simple mistakes that people might make because now everything's consistent. They don't have to learn lots of different things. So it really does help. It pays dividends in more than just code reuse when you spend time improving an API. It also helps you understand how the code works better, what was involved in it, you learn it better, and then you also can use it more easily because you've done the extra work necessary to make sure that you're not doing anything stupid, that it is easiest to use as it can be, that it's efficient. All of those things that you've done will pay you dividends going forwards. So that I feel like is really important to underscore here as we go into this. It is important to learn and important to get right for two different reasons. And I think that is something worth noting. Now, what I'd like to do is pop back to our Win32 render test. For those of you just joining us, let me just show you what this is. This is an outside Handmade Hero that just compiles in the Handmade Hero renderer. It's very small. So let me go ahead and show you the code here, right? I can't because we're in the wrong project. There we go. So really, here's just some simple code that puts together a simple scene. Again, not using the API at all. So all this stuff is not part of the API. Here is where we start using the render API. You can see very simple. It's just got a few simple calls, cube, sprite, right? That's all you need to know to use it. That renders the entire scene, basically. And then here's what a render loop looks like. Again, for startup, mostly Windows code. Here is the initialization for the OpenGL layer that you need to call for our renderer. That's really it right there. Here is the memory allocation. So you allocate the memory for the, you don't have to call us to do it. You allocate the memory. We may change that a little if we want this buffer to be something special, but that's a separate issue. So there's that. So anyway, that's one thing. And then this is all just initialization for the test scene, right? Again, not really related to the API. And then here's the use of the API. Again, very simple. This is just utility functions. You don't really need to use this. This is just giving you a way to figure out what region to draw in if you want a 16:9 window, right? So very simple. Something that sets up the camera. Again, this is not really using the API per se. You could use anything to generate as long as you can generate a camera matrix. So in terms of our render API, it's really just this. Very, very straightforward. You initialize a command buffer that's going to have everything in it. You say, here's a group of render commands I'm going to issue. Here is the camera transforms that I'm going to use for them. Here is the depth PL marker. Here's the scene. End of the depth PL marker. End of the render group. And then you issued it to OpenGL. So again, very, very simple. You're talking about an API that basically is just that for your entire render loop, which I think is pretty good. So I think that's all good, but we can still do better. And we can also make utility functions for some of these things that will simplify this. So one of the things that I often like to say is you want granularity to be something that the user is in control of whatever your API is. So for example, in this case, you can see we have a very high level of granularity here. So very, very fine granularity, where basically the user is making their own 4x4 camera matrix and has control over all of this stuff, right? The dolly, the shift, the pitch, the orbit, right? They're creating their own matrix, all of this stuff. And that's great, and you want that. Never get rid of the ability in an API for someone to micromanage what they're doing. However, you also want to provide high-level calls that do all those things together for people who don't know or don't care about how that thing works. So for example, when I look at all this code, I see an opportunity for us to provide some utility functions that, again, don't get rid of this. Make sure this code path still works, because you definitely want the person to be able to make their own matrices and be able to position the camera very specifically like that, however they want to. But we also should just make some nice camera utilities that allow you to just do this automatically. Because a lot of the times that's all you're going to want to do. Is just say, here's the point I'm looking at. I want to like spin around it this much and up this much, and here's the shift. Let's just make something where these parameters, you just feed those parameters in, and it works, right? So something like that seems like a really good addition to what we have made, because at that point, we could get rid of all this code too for people who, again, don't want to know how camera code necessarily works. They can sort of take advantage of the fact that we do know, and off we go, right? All right. So I think that's one thing we should look at. The other thing that I think we should look at is this depth peel stuff. So I don't necessarily know to what extent we need the depth peel to be as explicitly programmable as it currently is. I think one thing we could do is just always depth peel, and then just have some things that are outside the depth peel. Like, I don't know that we need multiple depth peel groups. So it may simplify the renderer as well as the API if we just said, look, render groups are either depth peeled or they're not, and you don't have to use a begin depth peel, end depth peel. You just say when you begin a render group whether it's depth peeled, right? That seems pretty easy to do. And I feel like we could do that really simply here by just actually adding that into the render group already and not really doing any optimization around it, meaning actually just call begin depth peel, end depth peel for you in the render group, for example. I think that might make things easier. Since the depth peels are cleared, I mean, the way we have the API now, because the depth peels themselves have a clear involved, I feel like that also means you really couldn't use multiple of them anyway. So we would have to change this API to support multiple depth peels in the first place. So I kind of feel like we could simplify that down because our renderer really doesn't support multiple depth peel passes, so why bother with this part of it, right? So I think we want to do that. Let's go ahead and start down this path. So there you go. I've now said everything I'm going to do. This is not going to be very complicated. We're just going to basically start down the path I said and do as much as we can today. That's really it. So if I jump here to the render loop, I'm going to start with the depth peel stuff because it's pretty basic. I'm going to hop over here into the render group code, and I'm going to I'm just going to look at that begin depth peel stuff. So here's begin depth peel, end depth peel. I'm going to jump to the render group, and I'm just going to put this in here so we can kind of look at what they do. So if you look at begin render group here, you can sort of see in the command structure as we're doing this, You can see that normally we call begin render group this way. I don't know if we're still using these generation IDs. I actually am very curious about that. I don't know to what extent we care about this stuff anymore. I feel like we should have been able to actually get rid of that at some point. I feel like those generation IDs can go. And unfortunately, I don't quite know if they can yet because we're sort of still relying on them. The generation IDs were just there to avoid having assets being evicted on a frame where they were getting used. And I don't think we actually really need to do that anymore because I'm pretty sure we can just make our asset eviction happen at a specific time nowadays. And I should state that a little differently. We kind of know already that the assets are evicted at a specific time anyway. So if you look at the OpenGL renderer, for example, oops. So here's Win32 Handmade OpenGL. And what you can see is if I jump down to the place where we actually look at a particular texture. Oh, sorry, I'm in the wrong file. I meant actually renderer OpenGL. We're not talking about we're talking about the platform non-specific OpenGL code, not the platform-specific OpenGL code. So if we look in here when we actually render something, what you can see is when we actually grab it, we don't care anymore about the loaded bitmap, right? Remember we were passing load and bitmap down here originally? If you look, we care not at all about loaded bitmaps anymore. And the reason for that is we now process our OpenGL, our textures. We now process those at a known time, which is right when OpenGL Manage Textures is called. Now, what we could very easily do, and we may actually want to do, is say that that happens actually on render. So meaning texture transfers are started at that time. And so, for example, let's suppose I did this. Right? This would be exactly what we would want to do, meaning we process these at this time. Unfortunately, there is one downside to this that we may not want. I'll fix this now too. I might as well. So what I'd like to do, yeah, you know what? I can also do it this way, and then we can do it in two stages. But let me continue what I was saying first, and then we can talk about that. Because this is something we wanted to get to next weekend is going to texture arrays anyway. But so let's suppose we just call OpenGL Manage Textures right here. So basically, at this time, we know that we're going to manage our textures. So we take the lock, get everything off the queue, process it all, and off we go, right? So if we know we've done all of those changes at this point, we know that we really don't need to worry anymore, I think, about those generation IDs, because we know that we are never going to do any evictions except at a very specific time, right, before we start the render process. Now, I think since those evictions happen like... since those evictions are going to happen when we're rendering, they're going to reuse a texture slot. Technically speaking, I don't know if really what you want to do is put them here, meaning we don't want to evict anything till we're done rendering that particular frame, right? Because any textures we may have used on this frame, we want to use them first, and then we want to evict them, right? So I think we may want the code to look more like that. But once it looks more like that, I think generation IDs become irrelevant, right? I don't think you really need them because I think most of the time the generation ID is really not relevant. Let's find out what it gets used for just in general. So let's suppose I got rid of that. What happens? So here we update them whenever we load. Here we, let's see. Here we check when we evict. And that's it. So really, if we just don't do that, right? If we just don't check generation has completed, I think we're done. Right? So I think that's basically it. Yeah, hold on one second. Sorry, I just wanted to close the door there. So let's take a look at what happens in the generation ID stuff. If I just remove this entirely, I think we'd be fine. And then we can get rid of that because we don't really need that anymore because we do update the textures at a known time. So in theory, we should be able to ignore that. But you know, you never know with multi-threaded code. We're going to have to double check and make sure everything's kosher first before we make that kind of a bold statement. So anyway, let me go ahead and get rid of that stuff here. Make sure that it's not involved anywhere anymore. And then we can test it lightly. It will not really be a definitive test for obvious reasons. Where is that generation ID from? There's another one there. Let me get rid of it. It's from the render group. Oops. Let me just get rid of the one in the render group. That'll generate. There we go. That'll generate other ones. So here we go. Oh. There we go. Sorry. And again, not doing anything interesting here, just removing vestigial remain to make sure that everything is kosher. Now, for sounds, as far as when sounds are evicted, it looks like we load them right when we use them. So in theory, that should make it impossible to ever evict enough in time. So I think those don't care, and also those were never checked in the first place. So those generation IDs weren't doing anything for us anyway. All right. Let's see, generation ID. Let me take a look at render group there and make sure that we don't actually ask for that anymore. There we go. Oops. There it is. Hey, that's a good to-do we got rid of. Sorry it's taking so long. Sometimes we gotta do a little house cleaning and it's kind of mundane. So we don't really, yeah. In fact, these to-dos all say pull this out, so that's a pretty good indication that maybe it should get pulled out. So in-flight generations, that should go away. This should go away. Operation lock. So I'm not 100% sure what that asset lock was actually bothering to do, but we'll check it out because I don't want to remove that lock yet. Let's take a quick look here. That gets rid of all of the generation ID code. I want to take a look at the begin asset lock code though, because that we may actually care about. Yeah, so that we need. We can eventually get rid of this, I think, because I think we probably would be able to, once we switch to the different texture system, we may be able to keep things more straightforward there. But the asset lock for updating the memory headers, that we don't want to get rid of. That would cause us issues for sure. So anyway. All right, so here's that render test. Let me go ahead and make sure our game is working as well, because that puts more stress on the asset system, certainly, because it's actually loading things. All right, so debug build of the game works okay. I'm going to try the optimized version of the game too. We don't have any really good way of testing our multi-threading. We don't have a really severe like burn-in kind of test that we would do, which is fine. We don't need to do that kind of testing during this phase of development anyway. But I'm just going to make sure that there's no obvious hangups, like that we didn't break anything that is immediately clear. So anyway, back to where we're going. So that begin render group, end render group, now that we pulled out that generation index, which we don't need anymore because we have a specific asset update time, I think we want to keep that, especially for OpenGL output. You can get fancier with other APIs. OpenGL really hates multi-threaded texture transfer. It's super hard to get it to work reliably across systems. Just multi-threading in general with OpenGL just doesn't work. Not enough drivers support it well enough. You can do it, and if you're on certain cards, it will work just fine. But it's just not, it's got issues. Buyer beware. Anyway, so as far as depth pooling is concerned, sort of what I was suggesting we might do is just weld these together with the beginning of the render group. So for example, in here, if we were to say, look, I do want to begin a render group with a depth peel, maybe that's just a thing we do explicitly. I'm going to, I don't know what the missing resource count is for here. I think that would just say, look, we don't want to render this frame. We count missing resources and see if we want to delay the frame by 1 frame or not, which we didn't do here. We could do that. That's kind of interesting, actually. Maybe we should look at that later. Anyway, when we do begin render group, what we could do is have 2 ways of beginning render group. We could do basically a depth peeled render group and a non-depth peeled render group. And so I guess what I'd say here is we could just say, I mean, we could just weld this together and be like, do you want to clear? Do you want a depth peel? And when you begin the render group, you say which of those you want. I don't know that that's great, but I'm going to try it. And we're going to see what happens. So let's suppose that this begin render group just takes some flags and it says what you want to do with it. I'm just going to try that and see if I like it. I don't know if I will. I might not. So let's just say I have an enum render group flags. And I'll have render clear. Do you want to clear? I guess handle translucency, or I guess like auto sort, something like that. Meaning do something that handles the sort automatically, or like handle overlapping transparency, or I don't know. Something like that. I got nothing. I don't know what to call that, but we're just going to go with that for now. So if you want to do a clear, you can specify that. If you want to handle transparency, you can specify that. And maybe I'll also say, like, there's sort of a third kind of thing that I might want to do in the future, which is that, so I don't know for sure, but I may just want to have the ability to do like 3D shapes versus 2D shapes. So I feel like we may also want to do like something like anti-alias edges, because to a certain extent we don't really need to run the multi-sampling path on anything other than the cubes, right? So like when we do our render group, we could choose to do no depth peeling and anti-aliasing on the cubes, and then we could choose to do anti-aliasing and, I'm sorry, depth peeling but no anti-aliasing on the things that aren't the cubes. You know what I mean? I don't really know if we want to do that, because it seems like maybe it's better to just allow everything to... Maybe that just gets too complicated, you know? I don't know. I'll just leave it like this for now. We'll see how it goes. All right, so here in the render group, I want one of these to basically say what the flags are. And what I'm going to do here, again, for the benefit of people who maybe don't necessarily know what's going on, I'm going to also have a render like default. And that's going to be one that does both of these, right? So it's this or this. And that's what you'll get if you just... So that way, if you're just doing one render group here, you would get the thing that works, you know, for just a game scene. If you don't know what you're doing, you can just slam everything through that path and it will work. It may not be the best thing for later when you're trying to do something more specific, but it will work, right? So then what we can do is put this stuff on here. I'm trying to think of, like, for depth clear and full clear, I don't know to what extent we were actually doing those. I don't know when we do like depth clear versus full clear. But maybe I'll put here, like, maybe I could put those in here. Yeah, so I'm going to look at when we're using that. I'm assuming it's for the debug. It is. So what would happen is here we would do that depth clear, right? And so I think that's probably just fine. I don't know if we have to make sure that we push a camera transform first before the clear in order to make sure the scissor rect is not messed up, but that's kind of a separate issue. As far as full clear is concerned, that's not really used other than in the same way. Yeah, so that's just what we would do at the beginning of that render group for clearing the screen anyway, is not particularly relevant either way. So I think we're good. I think we don't really have to worry too much about this. So I'm going to go ahead and say that'll work. I'm going to arbitrarily say that, and obviously I don't actually know, but that's fine. So then I'm going to get rid of those two depth peel pieces. So those depth peel things will go away. And I'm going to weld those in for now. So let's put these up in here as well as these. So if the render group is a depth peel render group, we need to remember that. And probably the easiest thing to do here is just store the flags that were used for us, you know? So what I can do is say, when we put this on here, the flags will be remembered. And that way we can test them later as necessary. I think that should do it. Yeah. So then what I'm going to do is I'm going to test these flags. And I'm going to see whether we need to do like a clear color or a clear depth. And I'm going to see whether or not we want to do a depth peel. So the way that I want to do this is say that at the moment, if we're doing handle transparency, you have to clear everything. That's just how we require it to be done, I believe, at the moment. So in this case, I will say like assert that both of these are true. I think that's what we want to do, meaning we want to say, hey, right now, if you're going to do a transparency pass, you have to clear. And if you didn't specify clear, then that's just an error, and you will be sad, Panda. In the future, we could try to figure out a way to support that, because you could actually copy the depth buffer or the color buffer into the first depth peel layer. So you could technically do that and actually have that work. I just don't know that we want to, right? So again, I'm just experimenting with this. I may decide this is not good. We'll see. But I'm going to at least try it first. So here's my depth peel. So in that case, that's all we needed to do. In this case, I think we also don't have, and I'm going to grab these two right here. We currently don't have a way to clear just the color. So we're also going to assert here. And again, these are just to make sure that no one tries to use it in that way yet, because we don't support it. We don't want them to be confused about why it's not working. We could start to try and support those later for people who want to do something fancier, right? But at the moment, we're not gonna. So here's our clear depth. And here's our full clear. And I think that's mostly it. This should really be, well, doesn't matter. Okay. Let's see what else we got here. Semicolon missing. Flags are off the render group. Oops. Flags are off the render group. Why this isn't just called group, I don't know. Because I guess I really like to type render group every time. It's like, what other group would be in this function that we would need to differentiate those two? So now what we want to do is make sure people aren't calling these manually. And so what we want to do is give them a name that will make sure that doesn't happen. So I'm just going to go ahead and underscore these so that basically everybody who is calling them cannot call them, and only the internal code will call them. And we may weld these together later on. So like I'm anticipating also kind of sort of getting rid of those, right? So we just want to give them a name that no one will use. And then what I can do is pull this stuff apart into, make this stuff a little bit more specific here as to how it's working, right? So we don't need this anymore. Now it's just that. And this should be render default, actually. Okay. And now for the game, the background color is just going to be for the render group. And how are we, so is this render group, how are we getting this render group? Who makes the start of the render group? Because I'm not sure what's happening there. Let me look at update and render world. So the render group actually gets created like outside. And I don't really know why. Yeah, I don't know what really is going on there. So let's take a look at a couple of things here. First of all, what is draw buffer supposed to be doing here? Like, what's going on there? What is that for? Yeah, that's just garbage. It's really just there to get the width in like one thing. Like we got to get rid of that as well. Like eliminate this and these entirely. All of this stuff, that comment could not be truer. I don't know what that's doing there. Let's hose that right away. All right. So now as far as depth clearing is concerned, so on here, when we go to do these commands, we really just want a depth clear right here. And that should be fine. For depth peeling, we want that to be done on the outside. We can look at that in a second. In here, I feel like this wants to be its own push-pull. Like this should be its own open-close. And the same would be true of here. So when this does rendered layered scene, that clear should have been just at the outset. I don't know why. I guess it's only if the layer count was 0 that we want to do it, but we kind of want to do it at all times anyway, in case there's a little bit of something missing in there. I don't know. Or we just don't want to do it at all. So I'm not sure. This is a little bit strange. I'm not sure why that's there. Yeah, it doesn't make a whole lot of sense. Let's see here. So I'm going to get rid of this entirely. I'd like to get rid of draw buffer as well. I'm just going to start icing that everywhere I see it. I think that's a vestigial remain from the old days. That's all stuff I want to update in a second. Here's draw buffer. I'm just getting rid of it. And I think that was just from the software renderer. We just never got rid of it. It's not necessary anymore. But it was still getting passed through all the time. So let's take a look here at cutscene.h. update and render title screen. I want to see where else that draw buffer is still hanging around. Like, I don't want that in there anywhere. So we need the width there. We know that's true, and that's fine. Okay. So I think that's all good, and we just need a way of getting the width into here. So some way of figuring out how big it is to get this, so we can get the standard camera parameters. And let me just look at what we're doing with the standard camera parameters to make sure we even really need to do that. Assume that's in renderer. Hey, not a lot of using of width in pixels there. So I guess that's the end of that. That's pretty funny. I guess that's, again, the bonus of cleaning up the code. You're like, hey, do I need to pass this? It's not even used. And then you can just get rid of it. All right. So now I think what I'd like to do is stop with the passing in of that, because I want people to be able to open their own render blocks pretty much as necessary. So this code right here that does the begin render group stuff, I kind of want that to be something that you use directly. And so I feel like these will now be able to open their own. And, you know, so now you can really think of the render commands structure as really the thing that gets passed around. That's the thing you're actually adding to. And render groups are just things you open and close as you wish, which is kind of what they were supposed to be. So this, I'm just going to say, look, we pass down the render commands, and you do whatever you want to do with that. We don't pass down the render group anymore. You create your own render group as necessary, right? And I think that's all we really need to do. So anyone who wants to make one of these now can just do it. Anyone who wants to do it, right, can just do this. And the other thing we could do is, if we wanted to, we could actually use this as a pointer, and the render group could, in fact, return a pointer. The reason we're not doing that is it's kind of just easier to put it on the stack, and the compiler probably has an easier time understanding what's going on. So this code is just written this way so that you don't have to keep taking the address of it. I don't know how valuable that really is, to be completely honest, but, you know. All right, so let's go in here and get that going. I don't remember what this is called. Render commands. Okay. So what I'd like to do here is just open up a render group when I actually need one. So right here is sort of where it starts, although I don't think it really needs to start here, so we can probably actually move this somewhere else. But point being, in here, what we want to say is, okay, we're going to do a render handle transparency, and we want to do a render clear color and a render depth clear. So we're going to do all three for this render group, and we are going to pass that background color and clear this. So then whenever we use these, I don't really remember where we use these. Well, we actually do start right there, so that's fine. So then after we push all the rendering on here, that's pretty much the end of our render group. And I suppose what I might, well, we'll take a look at that in a second. So then in here, if we actually wanted to render something else, I think if we wanted to render something else, we would just open the render group again in here, right? So what I want to do is say, okay, this is going to do the same thing again. And this time it's going to do no transparency. Probably. I don't know how we want to do this exactly, but I don't really know how we want to do that exactly. But we don't need to do just do that. Right? So that seems totally reasonable. And that way you just open and close render groups as you want them. You don't need that. And so for the title screen, and then we've also got the cutscenes. Those are both things that, again, can open their own as they wish. And those don't need to use the depth peeler at all. I don't think so anyway. I suppose actually now I look at it, it looks like we actually only need to open it if we're going to do this. So there's our background color. We don't have a title screen yet, so really this is sort of putting the cart before the horse, I suppose. There's nothing to render. But hey, we're clearing the screen, I guess, so we can see that the title screen would go here. We don't need to handle transparency on this. We just need to clear, and that's what we're going to do. And the same would be true for this, although I think this doesn't need to clear. So it doesn't need to clear, and it doesn't really need to use the depth buffer. So we can just clear just the depth buffer, even though we don't really need it to use the depth buffer, which is a little complicated. But yeah, we don't really have multimodal rendering in that sense. So at the moment, anyway, we don't have a way of saying just turn, oops, that's not what I wanted. We don't have a way of saying turn off depth testing. We could actually put that in here. And maybe we should. We probably don't need to, but I'll put it to do. So this way, at least we know. You know, if we want to do it, we can. And I don't know that we ever would care, because the title screens just probably aren't particularly interesting in that sense. But for the software render, you know, maybe we would want to put that in there someday, so that it could kind of say like, hey, look, this thing really would help if it didn't have to check a Z buffer. So let's tell it that you don't need to check a Z buffer for splitting these, right? And so that could come into play. For hardware rendering, no one's gonna care. Hardware won't care at all. Hardware's too fast. It's gonna render a layered cutscene, no problem, right? So I think that's all we really needed to do. I don't know to what extent this is working, so we have to go ahead and make sure that it actually is. I want to test both projects to make sure that we haven't broken anything. I also don't know... Okay, so we have broken something, in case you were wondering. Spatial lighting, where is my call stack? Here it is. Inside lighting test, who calls that? Oh. I say. Okay. Okay. Well, let's think about this a little bit more. Because our lighting is a little bit, oops, no, it's a little bit janky right now. So I hadn't really considered how that might flow through the pipeline. We may have to make a little bit of a special concession for that. So looking here, the root box is 0. I believe that the root box is 0 because there are no boxes. And I believe the reason there are no boxes is because we started the render group fresh right here. So I believe what actually has to happen is this begin render group has to be moved down in a sense, right? So for example, in here, what we would need to do is when this, with this stuff set up the way that it is, the lighting test actually has to be placed sort of here, unfortunately, right? So we need to kind of do that. It needs to happen as something that happens before you close the render group that you were working with. And for output lighting points and output lighting textures, I guess I don't remember when the lighting, so the lighting already got pushed on here. Yeah, the lighting's kind of a bit broken. We really want to clean up how that's working because as you can see, it's kind of a little janky here. So really, and output lighting textures is always going to be done as well. So I guess you just want to do like, you can see this is very messy. You want to do this, I think. And then for here, you want to say if you were going to show the lighting, then you clear everything and just make a render pass that does nothing but that. Right, something like this. And again, I think that the lighting is not finished yet, right? The lighting is kind of a work in progress, so it's not, I don't want to make much of a big deal about that. I want to just leave it, and I think that will kind of sort itself out over time. Also, do we actually have, I want to take a look at what happens too for our title screen. We haven't really done that in a while, so we should probably look at that too. It looks like we don't have a clean exit path for that. Play title screen. What's that going to do? So I might want to clean these up a little. You can see these are kind of ugly too. We're kind of going down a little bit of a rat hole here, but it's a rat hole that has a rat that's been bothering us. So I feel like it's a hole that you want to go into to get the rat out of, to a certain extent. So if you look at the way that we've got this set up, as far as the transient state is concerned, right? Oh, hey, there's still a main generation ID there. I don't really want that. There we go. If you look at the way this is set up, we have like game modes here, right? And you can kind of see the different game modes that we've got, each one of these, and they have their arena on it. I don't know like why we still even have this anymore. We don't really need that. And so I do wonder a little bit about this structure, to what extent this is actually relevant anymore. I kind of feel like it doesn't really need to be there. and we could collapse it down just into something more specific. I mean, it can still stay named transient state if it wants to, but like really it's just going to be these pointers and not this. So we'll have to think about that a little bit. But a lot of these things, again, can be made simpler now that we know how things work. We can simplify things down into stuff that doesn't actually require as much fancy footwork. So as far as the game, you know, you can see here we've got this arena stuff for the game state. I feel like that stuff can sort of just be systemicized a little bit more. And I feel like these things, like the Tran arena, like, let's just do it. I'm in a cleanup mood. Let's just get rid of that, and I want to see what's actually going in there, right? So we've got the assets are going in there. The lighting's going in there. Yeah, it's just not much stuff. I'm gonna nuke that. I know this is a lot of changes at once, and I apologize, but it's just like sometimes if you're in a cleanup mode and you're cleaning up the code, it just getting rid of stuff feels really good because you can simplify things and make it more reasonable, which is just always fun, right? So okay. Also, do we actually need the struct here? Yeah, I didn't think so. So let's kind of move along and see what's actually happening. So in here, we are allocating our game assets, right? And we get past the transient state. And we use the transient state to allocate these sort of temporary buffers, right? We don't really need to do that because we can't now, our ability to do temporary ops is actually a lot better than it used to be. We can just make temporary memory and have it go away in the middle of a function pretty easily, right? Especially in an init function, we wouldn't really need to pass a transient arena there for any of this stuff if we didn't want to. For lighting memory, the game mode, which is, you know, this stuff here, I feel like pretty much there should just be a temp here. So we've got the mode arena. I don't really know why probably we broke these down a little bit earlier before, right? So I feel like, you know, these arenas can be segmented pretty easily here, and you could just say, look, there's a temporary arena like this, and we could say that this just automatically gets cleared once per frame, and then you wouldn't even have to bracket the temporary lighting stuff at all. Right, you could just say like, oh, okay, you know, the game state, it just uses the frame arena for that, and off you go. I assume we know the game state in here because, yeah, we would have to. The transient state, on the other hand, I don't even know what that's for. Is it just for the asset pointer? I guess it's for the queues and stuff. So really that becomes more of a work distribution thing. You know what I mean? This will probably not be called transient state eventually, is what it's looking like to me, because it won't really be necessary. So when we do allocate game assets, I'm interested to know who I want to skip that for now because I'm interested to know who calls that and what I want to do exactly with that. But we can get rid of this now. And similarly, like most of this stuff that's being put on that temporary arena, like it can just it doesn't really need to be doing that anymore, right? Okay, let me just take a look. What else we got? So in terms of the world sims here, right? Same deal. So that transient arena, this can just be the frame arena. And similarly, like again, it doesn't really have to be cleared. Like it could be, but it doesn't have to be. So, you know, if you wanted to have begin sim, end sim, not really reset that memory, it totally could. I also don't know to what extent it actually already automatically does that. So the sim arena, it doesn't really bracket that. So this does right here because it knows it can. Yeah, and off you go. So if we wanted to, we could make this even more aggressive and not even have that, clear until the end of the frame. I don't know that we want to do that, but there are reasons we might want to do that eventually. Like if we want to be able to access stuff, and know that it lasts for the entire frame, we could start actually just not clearing that arena at all, right? And that's kind of interesting. Yeah. So let me inspect this a little bit. So what I would like to do here, I guess, too, is say, okay, so when we come in here to game update and render, when we actually have a functioning game state, what I'd like to do is make sure that we end up with something, yeah, so like the transient state doesn't really need to be done in the way that it's being done at the moment, right? Yeah. So what I'd like to do here is once we actually have the game mode going, whatever this game state is here, I'd like to go ahead and say, all right, that game state arena is just going to be like, it's going to be snapped as a begin temporary, right? And then we will clear it at the end before we conclude. And the render memory is not going to be a thing. Like that goes away. And So now anyone who wants to use the frame arena for rendering should just go ahead and do so. And that's going to be cleared every frame. I'm also going to assert that the frame arena has nothing in it. So like I should be able to do that, right, by looking at the memory arena and seeing if the platform memory block is there. I assume that once we clear, I don't know if we really give those blocks back. We do. So basically, I can assert that the frame arena I can assert that the current block has nothing in it. Right? So, yeah, continuing down that road, having the transient thing have an arena is really now only relevant because it wants to allocate one of these transient state things, but I really don't care about that. And furthermore, I don't really like the way the game mode thing is working here because we can't have multiple of them, which is a little weird. So really, yeah, like... It's not fabulous, I guess is what I'm saying. I don't love how this ended up because I feel like we want the game mode to have its own arenas. Like this mode arena should be owned by whoever is in here so that we can have multiple of these exist at the same time if we wanted to, you know? There's no real reason not to do that. And so, you know, the place where these get their memory from should really be coming from a more specific place. And then this stuff just gets flattened together, right? So game state just has this stuff in it. There's no point to this stuff, right? Like this would just come down here. And everyone just uses the game state for that. And then the game mode itself, it can have its own arena in there that would just get cleared out when it's done. You know what I'm saying? And we sort of do that with this, but you couldn't keep both of them at that point. So you'd rather have it so that the game mode is like a flushable thing that you can keep around if you wish. Like this should go in there. I'm going to real quick do this. We don't need that. And I don't know why we need the task with memory up there, but that's okay. Maybe because it gets used in there. So I'm going to go ahead and say that whenever we look at, you know, stuff like this, that operation lock. Do we even know if the operation lock should be on there and not on the assets? Like, I don't know if we even know that really, but maybe we do. But anyway, point being, inside the assets structure, we can really just store the game state pointer then if that's what we really need. Although, let's take a look at everyone who calls on the operation lock. So the operation lock is only called on the assets anyway. So that's, yeah, okay, fantastic. So that is just dumb to begin with, right? That should not have been in here. That's probably because of, again, old architectural things. So this is pretty great. Like, there's a lot of stuff we can clean up in here. And if there is a lot of stuff you can clean up, then you should, right? So I'm going to put this in here, and I'm going to leave that to do because I think we may want to get rid of it entirely. But anyway, point being, this now can be done thusly. I don't know why this wasn't marked volatile. Probably because you only ever use it in an atomic compare exchange, which will treat it as volatile. But I'm just going to mark it that way just so everyone knows that it is. So in here, I think the low priority queue needs to be accessible. So the assets would have to be able to get back to the game state there. I can leave this in here because I am still not thrilled about it. Any chance you're going to give me the begin task with memory? Probably not, huh? So this is just game state. And actually trans state. And, oops. Trans state and game state here are just the same. And really, this is going to be the same everywhere. So this transient state here in the memory structure, this is just that. And inside handmade.h, you can see kind of why this change occurs, right? The reason that the change occurs is because we now have the ability to articulate from the game to the platform layer what is and is not transient. Before it was the other way around. The platform layer articulated forwards what that was, whereas now we just say when we create an arena, is it restored or isn't it? You know what I mean? So now you don't need to pass information about what is the transient state and what is the game state. That's not necessary, right? So this is not necessary. You only need that. And then the arenas themselves say whether or not they were restored per block. So yeah, you know, it's just, again, 6 of one, half dozen of the other, but now we got to do some typing. To clean that up. Okay, so put on your track shoes or track fingertip something and just replace these as we go. Eventually we might be able to figure out what to do with those low priority queues. Maybe they get stuck on the asset system permanently, you know, for all I know. That's entirely feasible as a potential thing. You know, maybe that stuff can be made clearer. We'll certainly see. But, oops. For right now, I just have to... okay. So this is actually, as far as the arenas are concerned here, you can see that we have our non-restored memory, and then we sort of create all of our stuff in the non-restored memory pool for our assets because it doesn't get saved to disk, right? So for these are just places where we temporarily push something on. And we don't do any allocations in here at all, right? Well, we come through here. So these want to be done in a temporary way, and so I guess I will just say these are going to be, you know, they're just going to use that frame arena because we don't care what happens to them. And I feel like this stuff can be simplified down quite a bit. It's just a unfortunate thing of untangling a little bit of how we were doing it originally that we don't really need to do anymore, right? show me create worlds. I don't actually know what create world needs to do. Does it actually use this? It doesn't. So really, create worlds can just be that. Looks like. Okay. So this stuff is all pretty rote. Can get rid of that. These can get rid of these things entirely. Just again simplifies things. And this is really, all I am literally doing is just getting rid of that separation, because now the arenas remember that separation internally, which is just a feature we just didn't have originally, right? And there's a couple other things we're going to have to do in terms of making sure the code reloading works, but otherwise it should be pretty simple. Oops. What's going on? Why aren't we jumping? There we go. Sorry, this is kind of just taking a while and is going to be boring. That's just the nature of pulling something out. It's easy to do, but, you know, not particularly exciting. Especially since most people were past this thing. So, yeah, in terms of debug get game assets, we can really just do this, yeah, and get it that way. That's what I meant to do before. I just didn't change the actual pointer there. Oops. So, yeah, so for this, we don't care about this at all, so it should be sufficient to do this. This stuff is all not what we want. And this is just basics, very simple basics. So the only thing that's a little annoying is that when we allocate the game assets, we would like to do, so I am going to go ahead and just make this do an end temporary here, just to make sure that it has something it can use. Basically to get rid of whatever it's, you know, happens to use as temporary memory. Although I suppose it's, now that I think about it, I suppose it actually is doing that itself, so I suppose I don't really even need to do that. Allocate game assets. presumably also this stuff can go now, because since we have growable arenas, we don't really need to lock a maximum size on that either. Yeah. There's a lot of stuff we could simplify now, because the arenas are just a lot more powerful than they used to be. And I think that should mostly do it. So I don't actually know. Yeah, I don't actually know how we want to proceed on this, but we'll kind of play it by ear. So at this point now, we have the we sort of have the transient arena as merged in now with our frame, and the problem that we're going to have is that now we just need to make sure that our sort of our memory flashing will work properly when we reload things. So if we go back to the Win32 side of things, when you're in the platform, this game memory stuff, right? We don't really provide anything specific with game memory anymore on the Win32 side of things. So if you look at game state, right, we never touch it. And the reason for that is that that allocation is something that happens inside, that's something that happens inside the game and gets set there as something that the game, cares about, right? So in terms of what we need to make sure work when you do something like loop live code editing, in theory, what we've got now would kind of just work, but there are some issues with it, like as far as anything that's non-restored. So if we look here and we look at what's non-restored, you can see that it's like only the asset system that is non-restored memory. And so what happens is anytime this stuff is doing anything, it's going into the non-restored pool. What that means is that all of the things in the game asset structure that get allocated into the non-restored pool themselves should not actually get restored either. So the game asset pointer needs to not get restored. It needs to stay the same. If that's actually true, which it looks like it is in most cases, then we should be okay because it won't restore any of this at all. So the fact that it's all unrestored memory should be fine. I don't know if the tasks cause a problem. I think we shut down all running tasks before we start, so in theory that should be fine too. But I'm not 100% sure. So I want to check. So let's start with some basics to see if we work at all, right? So here we are in the game, and I'm going to go into world mode and just play, like I'll change the clear color or something, right? Just to make sure that we can reload this background color here. So just to make sure that we can reload this, I'm going to set the background color to be like some kind of red or something, and just see whether it reloads properly and doesn't grind to a screaming halt, right? And it didn't. And it didn't flash the screen either, so you could tell the assets were non-reloaded. I'm going to do it again. Again, looks pretty clear. I'm going to switch to debug, from debug to release. There's our frame rate jump, and that all seems good. I should try a loop. I don't remember how to do a loop, but let's try one. And as far as memory blocks are concerned, I don't really also remember. So one of the things that we have had a problem with, and you can see it there, is our debug system is not very good at avoiding string usage that's in the unreloaded blocks. One thing that some people do, and we could do, is just not unload the DLLs. And you get into a little bit of a problem there, where if you never unload DLLs, maybe eventually you get too many DLLs or something. But it would be nice if we could avoid having to do that, right? Like, so one thing we might consider doing there is just getting rid of that, because this stuff doesn't really work correctly with that, because specifically we aren't careful enough about making sure our strings get copied, right? Anyway, that's neither here nor there. I just wanted to make sure that was okay, and it all is, it looks like, at the moment. So that's fine. Now let's go back to debugging what I wanted to debug before, which is how those cutscenes are working, if those cutscenes are working. So going in here, you can see we get a problem. We've got a render group. Oh, just to be clear, since you can't see, I forgot you can't see what I'm doing. When I hit escape on the keyboard, you end up going through a code path that puts us out to cutscene mode, which we haven't maintained. And we should. It's just been in there kind of sitting around. It doesn't get used. But we should. And so what I wanted to do was, if you look here, if we hit escape, what's going to happen is it's going to delete the player who hit escape, and there's only one player in the game. If we can put in more than one player, and then it wouldn't. But if we hit escape, we get rid of the player in the game, and so then it'll switch to the title screen here. So I can show you that happening. I hit escape. We're going to go to play title screen, and play title screen is going to go to set game mode. So what that does, right, is it looks here to see if there are tasks that we're still running that are dependent on the game mode. Again, that's something we could probably fix by striating those things. If we need to wait, we look well, okay, I probably shouldn't have hit run because it jumped over that. Let's try that again. So there is no work that had to get done, so it comes out here, and it's going to clear the mode arena for this game mode. There it goes. And then it's going to switch the game mode to a different game mode, right? And the problem with that is, again, like when we actually go then to when we go to render the actual frame, so when the render commands get issued, they're bogus because some of them are pointing into something that actually exists on the world mode stack, right? It's actually here. So to be honest, fixing that, the way that that should have happened is the lighting textures should actually come back from the push. So really, that's just kind of a screw up in general. So I don't think I want to fix this by going down the game mode route yet. I'm happy we got rid of the transient arena. It wasn't, none of that stuff was needed to be in there really anymore, because our arenas are smarter than they used to be and can do that themselves. But this is not proper. This should come back from the render system. So these pieces of light data should be coming back from the render system, and they're not. So what we want to do is get rid of this. Like, that should not be there. And anyone who was using that needs to stop. What I would recommend is that the test textures, so the lighting textures here, those should come back from push lighting, is what should happen, right? Push lighting should give us back the place where we write our lighting to. And we might do that a little bit differently in the future, but for the moment, we definitely want the renderer to tell us where do we put our lighting textures, right? Push lighting should be in here somewhere. There it is. And so in here, right, when we get this stuff out, this going onto the temp arena is fine. And when we call that push lighting call here, and we pass the frame arena, that would work just fine. So what we can do temporarily is we can just go ahead and when we push these on, this source here, I'm just going to say that's actually going to get allocated itself. So that'll just be push struct lighting textures. And we can then play with this later, but that's exactly what we want there, something more like this. So now that will persist properly throughout the frame. And we just have to do a little bit more work to make sure that it's actually valid at render time. In fact, now I think about it, this still won't work because this frame is cleared before the render finishes. So we actually want to do that slightly differently than we were before. So I'll show you how we can do that in a second. All right, so I want to return these so that they can get pushed onto in that temporary arena. What did I call that? Light textures. Like so. Okay. So those light textures, if I run now, I'm still going to have the same problem, which is that they will go away. Only this time, they'll definitely go away because instead of being in the permanent store, they get freed right before we exit, and the renderer hasn't been invoked yet, right? Because that gets invoked on the platform side. But that's really no big deal. What we can do pretty easily is inside the handmade.cpp code, right? We have two choices. We can, if we want to, make the frame arena be something whose temporary actually lasts one round, right? So that's one option. The other option is we just get our lighting space passed into us, which also seems like a good idea, right? I don't know which one of those I want to do. Let me show you what this one would look like. So what we want to do here is say, okay, the frame arena, instead of getting cleared here, this is not where that happens. So the mode arena gets cleared every time round, but the frame arena actually gets cleared only when it goes to get used again, right? And this is then something that actually exists in the game state, and it just gets cleared at a strobe point, right? So it lasts outside. And we can totally do that. And it just depends which one we want. Since we don't really need to use this for anything else, I would lean towards moving the lighting into the renderer commands buffer proper. That seems like a better idea, but I just wanted to show how we would have done it if we wanted to do it here. It's not complicated, right? So here, what we would do, I just realized I gotta clear this. So I can't call this the first time around. How do I wanna, I probably wanna do this. So the first time we allocate, set it up there. And that way from then on, it'll always get checked. It'll always have it'll always be able to clear itself, or however you want to say that, right? So then that structure doesn't exist in a bogus place, right? Okay, so now let's go ahead and try to get our title screen stuff working. I don't actually know how much work it would be to get all those things working, so I'm going to take a little look at them, but I don't promise anything because I got to go on time today. What time is it? It's like 1 o'clock, 1:12. Yeah, I can't be too late today. I have something happening later today. Should be in the title screen here. We're not seeing the clear, right? And I'm not 100% sure if that's just because we need to be going through the depth peeler to see the clear, which is kind of a slightly different thing. I'm going to go ahead and just check that part because I don't know if that's render related or not. So this stuff here, I'm just going to quickly change this to render defaults. And same up here. Instead of this, I'm going to change it to render default. And that's just to check because I don't know to what extent the rendering subsystem is doing something stupid right now and doesn't necessarily. Yeah. Okay. So it's just that we don't actually support a lack of depth peels at the moment. So that's, I think, probably where we're at. So yeah, the cutscenes seem like they're working okay otherwise, but we really don't need cutscenes to go through the depth peeling, so I want to fix that. Yeah, this all looks pretty good. All right, let's go to Q&A. Do I use a wrist support while typing and using a mouse? I do for typing. I use this in front of the keyboard. It's just a, thick sort of foam pad. I do find it helps. I don't use one for mousing, but that's probably, I don't use the mouse that much, so I, don't really need one. Can you go through the rendering pipeline briefly again? What are the render commands and render groups? What are they used for, and when do they get initialized? Then what exactly is OpenGL doing with them? So that's a little bit broad. I mean, that's, multiple days worth of stuff that we've done. But briefly, render commands is a structure that is the thing that you provide to the renderer, whatever it is. So it basically gets initialized in the platform layer, and it can be specific to the platform layer. So, you can allocate the memory wherever you want. You can allocate the memory in graphics card memory if you want. You can do whatever you want if the for that platform, right? That gets passed to the game, and render groups are then buckets of commands that go into the render command structure, but the render group is just a utility struct you use to not have to store stuff, like where in the render commands you were, or what kind of group you're using at the time, things like this, right? So render group is just a utility wrapper around the render commands that people use. And that's it. OpenGL specifically takes the render commands that you have built and executes them in order. So it just goes through and actually serially does them. And right now it's not very efficient, and that's because we haven't done texture packing. So that's one of the big things we need to do is the texture packing sort of stuff. Hidden Triforces on the orphanage. So are there? I mean, I don't really know. That I didn't request any. Let's see. How can I start in game development without knowing much about C++? Well, it depends what you want to do, right? Like, if you want to be an engine programmer, you got to learn that stuff, because there are no such things as engines not written in C++. I mean, there's like maybe one successful one that I know of, which would be Minecraft was written in Java. But, you know, it's Minecraft. It's not a particularly good-looking game and not a particularly performant game either, so it kind of just is lucky that you happen to be able to do a world of blocks with a very short draw distance in Java, right? But that's sort of a separate issue. So yeah, I mean, it depends what you want to do. If you just want to make a game, you know, I don't know, you can do things of different degrees of simplicity, right? Like you can go... I want to say, like, you could start with something very simple like RPG Maker or Game Maker, right? Like, these are things designed for people who don't know how to program, and it can get you started. So it really just depends on what you want to do. If you want to actually work on serious game technology, that is a long learning process, and it's a dedicated field, and that's the stuff we do on Handmade Hero. I don't cover how to do, like, simple game, like, I want to script a game in Unity or whatever. There's plenty of tutorials out there for that sort of thing, and you can go grab them. And furthermore, like, things like Game Maker come with example games you can look at, right? Like, you don't need much to use those tools to make games of the form that the tool supports, right? If you want to make like a platformer, Game Maker's got like the stuff you need in there for it, and it's pretty straightforward and it works. And people have shipped games with it that are popular, right? Like, I can't think of what Game Maker ones would be off the top of my head, but like I think like Chasm probably was Game Maker, was it? I don't know if that's true. Yeah, I shouldn't say because I don't know off the top of my head like what's made in what, but like, you know, you can point to popular games that were made in like Game Maker. And you know, it's not an impediment to commercial success necessarily. What it is, though, you know, one of the problems that you do face nowadays is if you're just someone who doesn't really know much about programming and you use, Unity or Game Maker or something to make a game, one of the problems that you do have is what's the difference between your game and everyone else? There's literally 7,000 people a year doing exactly what you're doing. 7,000 teams a year doing exactly what you're doing. So if you can't program anything new and differentiate yourself, you'd better have good art, I guess is what I would say. Like you need, because you can't just be like bad art and bad programming and hey, we just downloaded Unity and used it. That you're just going to be, no one's going to care, right? So you need to have a plan for that. And it's important to understand, right? And so you gotta have something that differentiates you. And maybe you're like an amazing game designer and you just have like these ideas that people haven't had before about how to design a game. 99% of the people who think they're great at that are actually not very good, and you're just gonna design something exactly like everyone else, right? And so again, like, you have to be realistic. And so one of the things you have to understand is like, what are you trying to build? Why is anyone gonna care about that? Because the number 7,000 was not arbitrary. There literally are 7,000 new games on Steam every year now. Why is anyone going to buy your game? It can't just be because you downloaded Unity and put something together, because that's not good enough, right? You have to have something else. You have to understand what you are bringing to the table. That's one of the reasons I think game engine programming is a very good discipline to be involved in, because people always need it. There are very few people who know how to do it, and you can't just download Unity or download Game Maker because those companies themselves need to make the engine. So you can always have a job, even if it's just working on one of those engines, if you are a good engine programmer. If all you know how to do is script games, good luck, right? I feel like your employment prospects, if that's all you know how to do, are pretty darn limited, because anyone can learn how to write a script in Unity pretty quickly. And if they don't know all the core fundamentals, if they're not really good with vector math, if they don't have all of the things they would need to be like a really outstanding Unity programmer, for example, then what's the point? Like, why? A good engine programmer can also make a big difference on a Unity game or on a Unreal game, because they can write all this custom code that nobody else can do, right? So it's just, I feel like there's a lot to understand there when you're thinking about it, and people who don't understand the value of learning how to program games for real, I think they're in for a pretty rude awakening, because your competition is fierce out there. And if you think you're just going to download an engine and not know what you're doing and put together something that anyone cares about, all I can say is you better have great artists, right? Because they can pull it out for you, right? Really great artists can differentiate your game with the art. But if you don't have that, you're in a lot of trouble. Can you recommend any game engine source code that would be helpful to look over for general architecture, for example, the Doom engine, etc.? I feel like Quake is probably good for old school. For new school, like, the problem with Quake is it's not going to be multi-threaded. So game architecture in new days is going to have at least some multi-threading, and I don't know what to look for that. I mean, obviously you can look at the Unreal Engine if you want to, but good luck, right? Because it's massive. So I don't know how realistic that really is in terms of an educational process, but... As a reference, can you disclose how much you paid the artist for Handmade Hero? No, like, generally I wouldn't probably give out the details of someone else's contract. I would not necessarily be adverse to them giving out the details of their contract for a contractor, but like a contractor is their own business basically, and you know, if you tell people what they gave you on their game or whatever, it's maybe a little unfair to them in terms of negotiating. You know, maybe they charged you less than they should have, or you know, maybe they charge you more and it's fine. We try to pay well, so we probably paid good relative to other jobs that person had done. But, you know, again, I don't really want to do that for an independent contractor. I don't think that's appropriate. For the rest of the art, so that was Yangshin for the cutscenes, and she did the initial concept work and stuff. Anna took it over after she was working at Mali full time. And so she now, it would be hard to say what the budget would be because she just does it like part-time as we need stuff as part of her work here, which isn't the same as like billable hours on a contractor. I mean, one thing I can say is that in terms of looking at the market, I would say contract art tends to run somewhere between $35 and $65 an hour, depending on the experience of the contractor and where they are located and where you are located for US prices. Outside US, things can be totally different, right? $65 an hour is probably an insanely high contractor rate in Argentina, right? I pick Argentina because I happen to know some contract prices there, and like the dollar is much more depressed there in terms of economics, so that would be like a ludicrously high contract salary if it was an Argentinian company paying an Argentinian contractor, right? So I guess what I would say is I can't really give broad advice on something like that, but I would say that from what I've seen, when people quote prices, they tend to quote prices around that range. But that's for 2D art. And I couldn't tell you much about 3D art because we don't really use any. Quake 2 is pretty interesting to go through. Does it matter that much that it is not multi-threaded? Because at least it is only around 120,000 lines of code. And with Fabian's overview, is it a pretty good starting point? I mean, here's what I would say. Multi-threading is very important, and you will need to learn it. You'll need to learn probably even more than anything that we've done on Handmade Hero, because we've done pretty simple stuff. So if you're talking about like hardcore, like full engine multi-threading stuff, we haven't really done much of that on Handmade Hero and probably won't. So that's a little bit of a missing area that you would have to get into for full AAA kind of stuff. And that, again, that's if you're doing whole engine architecture. If you're not, you wouldn't necessarily need to know. As far as learning goes, I would say definitely look at Quake 2 because, you know, some things never get old. Like, the way that Quake 2 was architected is probably relevant to everybody. It's interesting probably to see the decisions that were made there and how it looked and how it was rendered and how it was structured for network play and everything else, right? So my opinion is that, like, what I was trying to say is you probably need more than that if you're really trying to understand a modern game architecture. But it still would be a great exercise, regardless, to go through Quake 2. Super off topic, but as someone who is older and perhaps a lot more experienced than someone like me who's younger, do you have anything to say regarding interpersonal issues? Ever encounter people giving you issues or being rude? Yes, of course. Even absolute bullies. Do you have any advice for that if one encounters that, even as an adult in university or at their job? Not really. I would say that generally speaking, the reason I like computer programming is because I don't have to interact with people. And I don't find interacting with people rewarding, and I generally don't find most people I interact with to be worth interacting with, is I guess how I would put it. So I don't have a lot of advice as far as like how to interact with people productively. That's something for a person who has a higher opinion of humanity to answer, if that makes sense. Like I like programming specifically because it is a mental activity that it only matters whether you are right about what you did and not about what other people's opinions are. And I find that generally speaking, humans don't form opinions particularly well. They also don't tend to care about data, and they don't tend to care about validating their opinions. So interacting with them is generally a pretty disappointing experience unless you just happen to agree on things or happen to have a similar outlook on things, right? The good news is the better you are at programming, the less you need to do it. If you're a very good programmer, you can get paid just to program. You can even get paid just to program on contract, not in an office. So you don't even have to interact with anybody who isn't your friend on a daily basis, which is nice. In the meantime, yeah, can't really help you in terms of advice on that. I'll go ahead and recommend Doom 3 as a learning engine since from what I can tell it meets all the criteria you just suggested on a modern API, has multi-threading. You know, I didn't know that they released the source code to Doom 3. That's pretty cool. Now that I think about it, I probably did read that and was like, oh, that's cool. But I didn't really remember that. That would be cool. I haven't looked at Doom 3. I also think Doom 3, like, you know my feelings on object-oriented programming. I don't like it. But the reality is a lot of AAA studios use at least some of it. Some use way too much of it. But I believe Doom 3 has object-oriented programming in it because John Carmack wasn't the only programmer on it. So I think there's C++ in there, more C++ than there used to be in like Quake 2, for example. So Doom 3 might also be valuable because you can see the kinds of OOP stuff that starts to come in a little more. It probably doesn't have millions, like it, you know, engines like Source 2 or something are like OOP out into the disaster zone, right? But you know, so you don't want to start there because just be like, what is going on? Whereas I think Doom probably has a little bit of OOP going on, and that would get you warmed up to that as well, which is probably useful, you know? All right, I'm gonna wrap it up. Do you think the performance of the game would be fine on the Intel iGPU or in general the integrated GPU? At the moment, well, we do need to fix our texture dispatch issue. So I'd like to put that aside. But at the moment, we until our lighting is a little more flexible, probably it's not very, like right now the lighting is kind of does this weird summation per pixel thing that we probably don't want to do and is a little too scatter-gathery. Like right now the lighting would, I think, prevent it from running particularly well on an iGPU from Intel, I think. So I would say in the long term, we will probably have a good shot at running reasonably on an integrated graphics part from Intel. Or for AMD, obviously, which tends to have better integrated graphics parts. on the current version of the render, probably I think you would have problems. Right now we have problems with the lighting. You can see that like in a cutscene, we're spending all of our time waiting for the graphics card, and a lot of it's like if we turn off the debugger, all this stuff, we almost spend no time at all, right? We're just sitting there waiting for the graphics card entirely. But when we are in the game, right? I don't know how we get into the game. Here we go. But when we are in the game, you can also see like, I mean, I think we're in debug mode at the moment, so it's a little bit of a non-test, but when we're running the game right now, our lighting, which we run on the CPU, is actually very slow as well, so it's, again, pretty hard to tell. But even that, you can see in the current situation, if you ignore the light propagation stuff and just focus on what the GPU has to do, you can see that fill rate is in fact a problem. I'm not sure if we can shrink down the amount of processing we do and still read anything. Not really. Oh, you know what? That's not going to matter because we don't change the render resolution anyway. I don't know if we have any way to really. Yeah, we don't. I mean, you can just see like, so there's the multi-sampling. If I turn that on and off, you can just see like our fill rate is an issue, right? Is all I'm trying to say. That will be really bad on Intel GPUs, and so that is, I think, you know, when we fix that up, I think we'd be in much better position. All right, I'm gonna shut it down there. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to pre-order the game on handmadehero.org, you can get the source code for it right now and play around with it if you would like. We didn't quite get to what I wanted to get to today in terms of finishing the... I wanted to check out those sprite push calls. So we'll probably do that next weekend. Next weekend, we will hopefully have time to do both things. So sprite push, just clean up those calls and make them a little bit more understandable and a little more flexible and probably a little faster too. At the moment, I think they're kind of a little bit too slow. But then also start down the road towards packed textures and texture arrays, because that's really going to hold back our performance a lot. And so just getting that out of the way, I feel like for a lot of those things like ground cover and things like that we want to have ways of making those things work quickly and easily so that we can put nice effects into the game as necessary. So that's really what I want to start focusing on, is to get that into position so that we can sort of have a more realistic picture about where our render slowness is. And I suspect it'll all end up being in that sort of lighting summation stuff, which we can then work on and try to figure out how we're going to mitigate in terms of making sure the lighting is efficient enough. So that's it. I'll be back next weekend with that. As always, if you want to check out what we've got on the handmadehero.org page, there's a bunch of resources here. The watch page will show the schedule at all times, so you know when we're going to be live streaming. It also will show the live stream, so you can really just do everything from that page if you want to. It's pretty handy. It also has the episode guide, so if you want to watch old episodes, that's it on there too. It has everything you need to watch the series right there. There's also the Handmade Fund if you want to support people who are doing work related to the series, like the episode guide. That gets paid for out of the Handmade Fund. It's a fun thing to do if you want to contribute to the community, and it comes with a bunch of bonus stuff for me that I put in a little bonus pack for people who want to support community efforts. Obviously, we also have the special Handmade Hero head you can click on if you want to get to the other sites from Molly Rocket and check out what we're doing. You can always click on the Handmade Hero head or sign up for our mailing list down here. All that stuff, again, is on handmadehero.org. It's pretty easy to get to if you want to check it out. That's it for this week. I'll be back next week when we hopefully can, like I said, start down the path of just cleaning up that render performance stuff with the texture arrays. That's the really big thorn in our side right now in terms of saying that the render is real because it's too amateur hour with a texture change per quad. We don't want to be going into the home stretch of actually developing the gameplay with that kind of nonsense in place. So it'll be good to get that out of there. Thanks for joining me. See you all next week. Have a good one, everybody.